We got notes here for lambda 4, special angles, special right triangles. There's two special right triangles that you need to memorize, the 30, 60, 90 and the 45, 45, 90. In the 30, 60, 90 triangle, the 90 meaning it's a right triangle, and your acute angles are 30 degrees and 60 degrees. There's always a short leg, a long leg, and a hypotenuse. Opposite the smallest angle, which is 30, is the smallest side, which we can call alpha or we can call the short leg. Opposite 60 is going to be the bigger leg compared to the smaller leg, and the bigger leg is always whatever the smaller leg is times the square root of 3. So if opposite 30 is alpha, it means opposite 60 has to be alpha times the square root of 3. Opposite 90 is always whatever the shorter leg is times 2. So if opposite 30 is alpha, opposite 90 is 2 times alpha. Quick example with numbers. Let's say that alpha was 4. That would make opposite 90 2 times 4, which is 8. That would make opposite 60 4 times the square root of 3, which we would just leave as 4 square roots of 3. Just a quick little example. In a 45, 45, 90, the two legs are the same length, and that's because of the converse to isosceles triangle theorem from geometry. Since the 45s are the same, the sides opposite those have to be the same. The hypotenuse is always going to be whatever the leg is times the square root of 2. Quick example with numbers. Let's say that beta was 8. That would make this beta also 8. It would make this 8 square roots of 2. If you know those facts, 45, 45, 90 and the 30, 60, 90, you can do lots and lots and lots and lots of problems. So we need to fill this table out, and you're going to have a quiz over this tomorrow. And the quiz is going to be the same as the front page of these notes. Not the thing at the top, but this table here. In this table, you got to fill in all these missing numbers. And it is much easier than you could possibly imagine. Let's first look at this angle that's 0 degrees. On a coordinate plane, 0 degrees is on the positive x-axis. At that point, we have to know what x, y, and r are. At that point, x is going to be a positive number. You can pick any number you want. Most people are going to say, let's make it a unit circle, which makes that a 1. You don't have to. You can make x any positive number. No matter what you pick x to be, y has to be 0. And r is dependent upon x. If you pick x to be 10, then r has to also be 10. So we picked x to be 1, so r is 1. Sine, as we all know, so this is saying sine of 0 degrees for this first problem. So you take sine and then this angle, sine of 0 degrees. Well, that's y over r. Y over r is 0 over 1, which of course is 0. Cosine of 0 degrees is x over r, which is 1 over 1, which reduces to 1. Tangent of 0 degrees is y over x, which reduces to 0. Then we have these reciprocal trig functions. Reciprocal of sine is cosecant. Reciprocal of 0 is undefined. Then we have secant. Secant is reciprocal of cosine. Reciprocate 1, you get 1. And then finally, cotangent and tangent are reciprocals. The reciprocal of 0 is undefined. So we got that finished already. The next angle that we have here is 90 degrees or pi over 2, which are the same thing. 90 degrees and pi over 2 radians is the same. That's a positive y-axis. At that point, x is 0. Technically, y could be whatever you want, as long as it's positive. I'm going to choose it to be 1, which gives me no choice for r. It's also 1. Sine of 90 degrees, or sine of pi over 2, is going to be y over r. 1 divided by 1 is 1. Cosine of pi over 2 is going to be x over r, which reduces to 0. Tangent is y over x. That's 1 over 0, which is undefined. Then we reciprocate. Sine and cosecant, reciprocal of 1 is 1. Secant and cosine, reciprocal of 0 is undefined. Cotangent and tangent, the reciprocal of undefined is 0. I'm going to continue to repeat this for all of these angles that we have here, the 180, 270, and 360. If we go over here on the negative x-axis, x can be any negative number that we choose. I'm going to choose it to be -1. Y would then be 0, because we didn't go up or down. R is the same as x as far as its absolute value is concerned, but R is always positive, so it's 1. Sine of 180 degrees is 0 over 1, which is 0. Cosine is x over r, that's -1 over 1, which is -1. Tangent is y over x, that's 0 over -1, which is 0. Next we have cosecant, reciprocal of sine, reciprocal of 0 is undefined. Secant and cosecant are reciprocals, reciprocal of -1 is 1. Tangent and cotangent, reciprocal of 0 is undefined. Next we have 270, just down here. At that point, x is 0, y is a negative number. I'm going to choose it to be -1, and that would make r +1. So sine of 270. Y over r. -1 over 1, which reduces to -1. Cosine is x over r, which reduces to 0. Tangent is y over x, which is undefined. Reciprocate, reciprocate, reciprocate. Lastly, we have 360 degrees, or 2 pi. Well, that takes us back to where we started. 360 degrees, or 2 pi, is the same as 0 degrees, or 0 pi. So the answers we have up here are the same answers that we're going to have down here. 0, 1, 0, undefined, 1, and undefined. So, finished. Just by knowing what x, y, and r are on the axes. This next table is very similar. We got to figure out what cosine and sine are of all these angles, and I could have asked you any of these trig functions. Could be tangent, cotangent, cosecant, or secant. It's all done the same way as long as you know the proper ratios. Speaking of proper ratios, cosine of theta is always x over r, and sine of theta is always y over r. So the first angle we have is 0 degrees, and we just did this up above. 0 degrees is on the positive x-axis. That location, we could say that x is 1, r is also 1, y has to be 0. So cosine is x over r, that's 1 over 1, which reduces to 1. Sine of theta is y over r, that's 0 over 1, which reduces to 0. We just did that up above. Tell you what, let's also do the 90 degrees next. In the 180, we did those up above as well. It's the same thing, same question. So 90 degrees is here. So in this location, x is 0, because we did not go left or right. Y is 1, r is also 1. So cosine of 90 degrees is x over r, that's 0 over 1, which is 0. Sine of 90 degrees is y over r, that's 1 over 1, which reduces to 1. Let's do this 180 next also, because we've already done that. It's nothing new, we just did it up above. 180 is over here. That location, x is a -1, y is 0, and r is 1. So cosine is x, which is -1, over r, which is 1. That reduces to -1. Sine is 0 over 1, because it's y over r, which reduces to 0. All right, now let's do this 30 degrees. So we want to figure out what cosine of 30 degrees is. So we draw a 30-degree angle in standard position, making a right triangle. We got 30 in there. We got this other one is 60. When you do this, you have the choice to pick one side, any number that you want. The other sides are dependent on those choices. I recommend that you pick the smallest side to be 1 and then make the other choices based upon that. I think that's going to give you the most success. Some people like to always make the radius 1, so it's a unit circle. You're welcome to do that. But I am not going to do that here. Opposite 30 is the smallest side, because it's the smallest angle. I'm going to call that 1. If that's 1, according to the top of my notes, opposite 60 is that number 1 times the square root of 3. 1 times the square root of 3 is square root of 3. Opposite 90 is whatever's opposite 30 times 2. Opposite 30 is 1. 1 times 2 is 2. Now, if all that's true, and believe me it is, for me to do cosine of 30 degrees, I just take x, which is 1, over r, which is 2. Cosine of 30 is 1/2. To do sine of 30 degrees, I just wrote that wrong, I'm sorry. Cosine is x over r. X is the square root of 3. This is the x value, this is the r value, and I just did it incorrectly a moment ago. That's square root of 3 over 2 for cosine. Sine is y over r. This is y and this is r. So sine of 30 degrees is 1 over 2, which is 1/2. Next we have 45 degrees. We need to figure out what sine and cosine of 45 degrees is. I'm just going to erase this. I guess I'm not going to erase it. So 45 degrees. It's in quadrant 1. Make a right triangle, so we have a 45, 45, 90. Once again, when you do this, you can pick one of the sides, any number you want. I'm going to choose opposite 45 to be 1. If opposite 45 is 1, opposite the other 45 is also 1. According to the facts of a 45, 45, 90, whatever is opposite 45, opposite 90 is that number times the square root of 2. 1 times the square root of 2 is the square root of 2. So we need to figure out what cosine of 45 degrees is. It's x over r. That's 1 over the square root of 2. This needs rationalized, which is going to be square root of 2 over 2. To rationalize it, you multiply the top and bottom by the square root that's on the bottom. Sine of 45 degrees is y, which is 1 over r, which is square root of 2. Same thing. Rationalize it, we get square root of 2 over 2. Next we go to cosine of 60 degrees. I'm going to get rid of some of this just so I have some space. If you need to see it again, rewind and watch it again. 60 degrees, that is also in quadrant 1. Once again, I recommend you take the smallest side, which is going to be opposite 30, and make it 1. Opposite 60 is that number times the square root of 3. Opposite 90 is whatever is opposite 30 doubled. 1 times 2 is 2. So cosine of 60 degrees is x, which is 1, over r, which is 2. Sine of 60 degrees is y, which is square root of 3, over r, which is 2. This is 1/2. This is square root of 3 over 2. Next we have 120 degrees. I'm going to erase this once again just so I have some space. I don't recommend you erasing your notes. 120 degrees, that falls in the quadrant 2. You need to know what the reference angle is if that's 120. If this is 120 to here and it's 180 over to here, it means the angle that we're missing is the difference between 180 and and 120, which is 60 degrees. That's 60, that makes this other angle up here 30. It's a 30, 60, 90. Make opposite 30 any number you want. I recommend a -1. It's negative because we went left. Your signs matter here. We went left, so it's negative. Opposite 90 is double that, but it's not double the negative, it's just double the 1. R is always positive. Opposite 60 is whatever's opposite 30 times the square root of 3, but once again, the sign matters. In quadrant 2, we went up, so it's a positive square root of 3. It's not negative. Negatives and positives depend on the direction you go. So cosine of 120 degrees is x, which is -1, over r, which is 2. So it's -1/2. Sine of 120 degrees is y, which is square root of 3, over r, which is 2. Next we have 135 degrees. I'm going to erase this once again so I have space. Some of it's not going to erase, of course, because I'm an idiot. 135 degrees puts us into quadrant 2. That makes the reference angle 45. So it's a 45, 45, 90. Opposite 45 we're going to call -1 because we went left. Opposite the other 45 is +1 because we're going up. It makes the hypotenuse square root of 2. Therefore, cosine of 135 degrees is -1 over square root of 2. That rationalizes to square root of 2 over 2, and that's negative, of course. Sine of 135 degrees is y over r, which rationalizes to square root of 2 over 2. Alright, got one more of these to do. People are beating on my door right now, so I need to hurry. 150 degrees is also in quadrant 2. That makes the reference angle 30. Opposite 30 I'm going to call 1. Opposite 60 is then going to be the square root of 3. We went left, so it's negative. Opposite 90 is going to be doubled what's opposite 30. So cosine of 150 is x, which is negative square root of 3, over r, which is 2. Sine of 150 is y over r. And there we go. Once again, you have a quiz over both of these tables tomorrow. You got to fill it all in from memory. Well, I'd work it out like I worked it out here, not from memory. And you cannot use a calculator. You're supposed to find the exact value, and you're supposed to not use a calculator. So number 1 is cosine of 60 degrees. Cosine is x over r. If we draw a 60-degree angle from standard position, we end up with a 30, 60, 90 triangle. Opposite 30, we can call whatever we want. I'm going to call it a 1. Once you call that a 1, the other sides are dependent upon that 1. Opposite 90, which is r, is always twice opposite 30. 2 times 1 is 2. Whatever's opposite 30, which is a 1, opposite 60 is that times the square root of 3. So to answer the question, what is cosine of 60 degrees? It's 1 over 2. Finished. Number 2 is in radians, and not only is it in radians, the angle that you're given, 9 pi over 4, that is bigger than 1 complete revolution. Tangent of 9 pi over 4 is y over x. Tangent's always y over x. You might choose to find a coterminal angle because the angle that we're given is bigger than 1 complete revolution. 1 complete revolution in radians is 2 pi. 2 pi is a fraction. with 4 as the denominator is 8 pi over 4. So if you subtract those, you end up with pi over 4. So finding tangent of 9 pi over 4 is the same as finding tangent of pi over 4. Let's figure out where that falls in the coordinate plane. We got 0 pi over 4. Complete revolution is 8 pi over 4. That's the same as 2 pi. Half a revolution then is 4 pi over 4. Halfway between 0 and 4 is 2 pi over 4. Halfway between 0 and 2 pi over 4 would be 1 pi over 4. And since we know that 2 pi over 4 is 90 degrees, then that means half of that is going to be 45 degrees. Pi over 4 is a 45, 45, 90 triangle. In that, opposite of the 45s are 1. Opposite 90 is that times the square root of 2. Tangent of 9 pi over 4, which we've already said is y over x, is 1 over 1, which reduces to 1. So that's it for number 2. Number 3, we have cotangent of 45 degrees. 45 degrees, once again, is in quadrant 1. Cotangent is the reciprocal of tangent, so it's x over y. It's a special right triangle. It's 45, 45, 90. The legs are the same length. The hypotenuse is the leg times the square root of 2. That makes cotangent of 45 degrees 1 over 1, which is 1. Finish with number 3. Number 4 is cosecant of an angle. Cosecant is reciprocal of sine, so it's r over y. Negative 7 pi over 2 is not an angle in one complete revolution, so you may choose to find a coterminal angle. I'm going to do that for this problem. So negative 7 pi over 2, I want it to be a positive angle. I'm going to add several revolutions to this. I'm going to add to this 8 pi over 2. That's 2 complete revolutions that I'm adding to this. If I add 2 revolutions to this, I'm going to end up with 1 pi over 2, which is between 0 and 2 pi. So if I start here at 0 pi over 2, a complete revolution is 4 pi over 2. Half a revolution, I should say, is 2 pi over 2. Halfway between 0 and 2 is pi over 2. So the angle that we're doing for this problem is actually a quadrantal angle. It's at 90 degrees, or pi over 2. At that location, x is 0. Y can be any positive number of your choosing. I'm going to choose to make it 1. R is going to be the same as the y value in that case. So cosecant, which is r over y, is 1 over 1, which reduces to 1. That problem is finished. Number 5, we have sine of 225 degrees. Sine is y over r. 225 degrees puts us into quadrant 3. That makes the reference angle, which is right here. 225 minus 180, because this here is 180, that makes this a 45 degree angle. So 45, 45, 90. Opposite our 45s, we're going to call 1. We're in quadrant 3, so those 1s are negative. We went left and we went down. The hypotenuse then is 1 times the square root of 2, which is the square root of 2. R is always positive. That makes sine of 225y, which is negative 1 over r, which is square root of 2. If you rationalize your denominator, multiply the top and bottom by square root of 2, you get negative square root of 2 over 2. That finishes number 5. Number 6, we have secant of negative pi over 4. Typically, I will find a coterminal angle if I have a negative angle. I'm not going to this time, just to show you what you can do. Secant and cosine are reciprocals, so this is r over x. Negative pi over 4. If we count backwards and we say we're starting out at 0 pi over 4, and we go clockwise, a complete revolution then is going to be negative 8 pi over 4. Half a revolution going in the clockwise manner would be negative 4 pi over 4. Halfway between 0 going in this direction, halfway between 0 and negative 4 is negative 2. Got negative 2 pi over 4. And I'm trying to put in negative 1 pi over 4, and I can see that negative 1 is halfway between 0 and negative 2. Puts me in quadrant 4. So I want negative pi over 4, which means that that reference angle is positive pi over 4. That's 1/4 of pi. Pi is 180. 1/4 of 180 is 45 degrees. So it's a 45, 45, 90. Opposite of my 45s are 1s. Take into consideration the quadrant you're in. We went to the right, so x is positive. We went down, so y is negative. The hypotenuse is the leg times the square root of 2. Secant, then, is r, which is the square root of 2, over x, which is 1, which reduces to the square root of 2. That finishes that section. Now let's use our calculator. When doing example B, use your calculator to approximate each value to 4 decimal places. You have to make sure it's in the right mode. Since number 1 has a degree measure, make sure your calculator is in degree mode. If you don't know how to change to degree mode, ask me and I will show you. I think you just hit mode and then go for angles and select degrees and hit enter. So you would type this in just as you see it in your calculator if it's in the right mode. 4 decimal places, you should get negative 0.1736. The second problem, which is also in degrees, your calculator does not have cosecant in it. So cosecant is equivalent to the reciprocal of sine. So you type that into your calculator. If you do that, you're going to get 1.7531. Number 3, you're going to have to convert the degrees, the minutes and seconds into degrees. So you would type in cosine, and then we have our angle. This is how you put it in your calculator. 72 plus 30 over 60 to change the minutes into degrees, and then 30 over 3,600. 30 over 3,600 changes the seconds into minutes and then degrees. And if you put that in your calculator, hit enter, you're going to get approximately 0.3006. Now this last problem, number 4, it's in radians because there's no degree symbol. So in your calculator, before you do this, you have to hit second, calculate, scratch that, don't hit that. Hit mode, and then change the mode to radian mode. Type this in just as you see it, and you should get negative 0.1679er. Reminder, you have a quiz over the first page of the notes. Those tables, you got to fill in all the numbers without a calculator, just with a pencil and your brain.